and we have a controlled levitation UFO. So it's controlled by a joystick. You can move it around. When it hits the edge, a LED pops on, a buzzer starts buzzing, let you know that you've hit the limit of the board. All four sides. Stills allows you to come back the opposite direction off the wall and or slide along the wall.
So pretty much we're soaking the superconductor inside our UFO in liquid nitrogen because the superconductor inside,
there we go.
We're using a principle called the Meissner effect, which requires a superconductor to be supercooled to about 80 degrees Kelvin. Once it's down at that temperature, the superconductor basically naturally opposes any magnetic field that it comes in contact with. So it's sitting above a bed of magnets.
With the film we've got there, there's actually a gloss black veneer on top that's about a 1/16 inch thick, so we're losing, so we only get, there we go. Now that's some serious floating.
Now it's floating.
Right, now show the motion with the joystick now.
Yeah, so pretty easy.
So our whole box is built out of acrylic. We have gloss and satin and clear, so you can see, if we turn it around, you'll be able to see all the motion inside.
The original design came from a 3D printer. Basically, the nozzle would have been flipped the other way around for a 3D printer. There's two crossbars that are right here. So when the sides move, they will move at the same time, and you can basically move it in 2 dimensions pretty easily. So in a 3-dimensional printer, they would have had a Z-axis. We basically made 2/3 of a 3D printer. So
Can we hit the LEDs just then, in case they can see?
So the LEDs and a buzzer go off whenever you hit an edge. That's done by 4 different switches that are underneath the carriage, and they'll come into contact with the side. So as soon as they come in contact, they communicate with the pick to turn the LEDs and the buzzer on at the same time. See if it'll make that sound, and it'll get stuck. And we didn't want it to do that when it was running into the side of the on its edge. We're just running off of 2 picks, and the inputs are the 4 different switches, and then we have a digital joystick. And there's when the joystick's on, it goes in that direction.
So we use 2 picks to allow us to do 2 degrees of motion at once, so we can move diagonally with this system.
We could have powered it off of 1 pick, but it was really easy to do it off of 2 picks since they were looking at different inputs. And there we go. So I mean, it'll go, but yeah, we got diagonal motion out of that. The motors are ran by some easy drivers that we got from SparkFun. On one side of our breadboard, we have 12 volts that powers up the LEDs, the buzzer, and the motors because they're rated at 12 volts. And actually on our easy drivers, they have a 5-volt regulator on them. So we branched that to the other side to power up the picks. And we just have 5 transistors that are sent so the picks can communicate with the LEDs and the buzzer at the same time.
So this here is the superconductor. It's a little 1-inch disc, about 1/8 inch thick. It is a very complicated compound that I can't say. And so we've got it in this little polystyrene igloo, a UFO. It's got a small cavity inside, so we can pour liquid nitrogen inside and keep it cool longer. If we were to just plop this down, just from air currents, it would heat up in about 15 seconds. With this, it can run for over 45. With the larger one we have, it can do 2.5. 4 magnets here, which are in a checkerboard pattern, and so they create kind of a node in the center of very bent magnetic fields. The superconductor resists any magnetic fields passing through it, and will act as whatever magnet it needs to be to resist those magnetic fields and keep itself levitated.